Okay, here are the notes for logarithms. Oh, I gotta zoom out. Logarithms worksheet 2. These are the notes. Okay, so we started working with logarithms, and today we're going to see how we focus on just looking at bases and exponents. If we just look at this along those lines with bases and exponents, this is going to be pretty easy. Okay, so let's just jump right in here. Number one, it's gonna, I think the problems will say evaluate each logarithm. On the previous assignment on worksheet 1, we kind of had the base and the other number try to match, and then the answer was the exponent. Here, right, it was like this. If we can get this number to match with this, we were able to get the answer, right? Well, we're going to do it a little differently today. We're still going to get the answer, but I like this approach better because, again, you work with bases and exponents, and you kind of don't work with logarithms. You work with something that you're familiar with. Okay, which is, again, bases and exponents. So what you're going to do is you're going to, step 1, convert to exponential form. You're going to convert it to exponential form. That's step 1. And in order to do that, whatever this logarithm is, right, because we're not familiar with this language, we're familiar more with bases and exponents. What you're going to first have to do is you're going to have to write this. And remember, we have to have an equal sign and like another part over here. But since there's no part or no piece over here, we're going to put an X there. So the first thing is you're going to do is to make sure you add this part. You put equals X, right? It has nothing that it's equal to, right? We need all these parts, an equal sign and something on this side. We're going to add that part. You're going to put equals X. And then how do you convert this, right? We learned this in the first worksheet, how to convert from logarithmic form to exponential form. You go counterclockwise. Remember that? Counterclockwise. And once you do that, now your equation, right, because it has an equal sign, now you convert it from logarithm form to exponential form. This is what you're going to have. You'll have 9, right, starting with the base, 9 to the power of x equals, 9 to the power of x equals 81. That is the first thing you need to do. Convert this logarithm into exponential form. This is the language we're familiar with. Step 2. Now you're going to take this in step 2, 9 to the power of x is equal to 81. And what you're going to see here and what you're going to practice here is to get the same base. Get the same base. We're working with bases and exponents. Bases and exponents. This one has a base and an exponent. This one does. Can I rewrite 81 with a base of 9? Yeah, you can. You're going to change this 81, right? This will be 9 to the power of x equals to what? Well, 81 can be written as 9 to the power of what? 2, right? 9 squared. 9 squared is 81. Right? So we got the same base. It'll be the base is this 9. We got this base to be the same as this base. All right, last step. Step 3. Right here we got the same base. The bases are 9, right? Same base. In this case, it'll be the same base of 9. Other problems will be a different same base. But honestly, once you get the same base, you don't need to look here no more. And step 3 is to do the solving part. Step 3 is to solve. Well, how do you solve this? Well, once you got this base to be equal to this base, and it doesn't matter what number it is, once this is equal to this, then we can set the exponents or the powers equal to each other. And here there's really nothing to solve, but it just tells you what the answer is. X equals 2. It says x equals 2. That's the answer, x equals 2. All right, this was a simple one. All right, the others won't take this long. Here I pretty much outlined and explained all the steps. Okay, here we go. Let's go to number 2. Number 2, log 232. Okay, step 1, what was it? Oh, I don't want to work in logarithmic form. Convert to what? Convert to exponential form. That's the language that we're familiar with. Convert to exponential form. So that means log 232. And remember, you need to put this part equals x. Equals x. We need an equal sign and we need something over here. So how do we convert this logarithm? It's still a logarithm. How do you convert it to exponential form? Remember, you go counterclockwise. So that's going to read 2 to the power of x equals 32. Okay, I converted it to exponential form. Step 1, done. What was step 2? Get the same base. So I got 2 to the power of x is equal to 2 to the power of x is equal to 32. That's sloppy. Well, here's the smaller number. 2 is a base here. 2 to the power of x. Can I write 32 to a power of 2? Well, let's see. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. Ah, there you go. So I'm going to get the same base. 2 to the x equals what? 2 to the 5. We got these bases to be the same. That's what you want to do. See, the bases are the same. I got a base of 2 and I got a base of 2. And then, well, step 3 is the solving part, but as you can see here, there's really nothing to solve. When these are the same, if 2 is equal to 2, then we can kind of ignore that and drop that, and we put this, the exponent parts equal to each other. And there's nothing to solve. It's telling you the answer, x equals 5. The other problems will have something to solve, so don't think that's it. Keep watching. So look at the way these next problems follow. They're going to get a little bit more complicated. Number 3. Okay, so now I have log 3 of 1 over 27. I'm going to do step 1 and convert it to exponential form. All right, I'm going to do this. That'll be, it's starting from the base. 3 to the power of x equals 1 over 27. Okay, this is step 1. I converted it to exponential form. Now I'm going to do what? Step 2, which is to try to get the same base. Here I got a 3. I'm going to leave it there. Can I write 27 with a base of 3? Sure. 27 is 3 to the power of what? 3. 27 is the same as 3 to the power of 3. But remember, in the previous assignment, we don't want this like this with a 1 over it, so we move it up. So that's something new. We want to move this up because I only want a base and an exponent. I don't want kind of like a fraction like this. So you move it up, and we know that when we move something with powers and exponents, and you can move them up or down from denominator to numerator, or from numerator to denominator. But when you do that, that switches the sign of the exponent. So now you really have what? 3 to the power of x equals 3. See, now they're at their same level. 3 to the power of what? Negative 3. Right? Because that's a positive 3, but when you move it up, this is the end of step 2. Right? We get the same base. We got the same bases right here. And step 3 is to solve, but you know. Once the bases are the same, you don't have to look at them. You just solve this. Well, there's nothing to solve. You get x equals negative 3. Okay, that's 3. Let's go to 4. Log 32, 2. Well, we're going to start with log 32, 2 equals x, right? We got to change it to exponential form first. You got to add this part. We're going to change it to work with just bases and exponents in exponential form. That's going to be 32 to the power of x equals 2. Okay, now what? Well, here the base is 2. Can 32 be written with a base of 2? Yes, it can. 32 happens to be 2 to the power of 5. 2 to the power of 5 is 32, and then with this x out here, right, 32 is 2 to the power of 5. And then you have a power. Remember, when you have a power raised to another power, they multiply. And this one doesn't have a power, so what do you put when it doesn't have a power? 2, or every number, any number, 2 is right now just to the power of 1. There's only 1, 2. Okay? And now we have what? 2 to the power of 5x, right? Those multiply. 2 to the power of 5x equals 2 to the power of 1. So here we finished step 1. We changed it into exponential form. Here I finished step 2, which was to what? Get the same base. Now how do I solve? How do I solve this? Well, again, once the bases are the same, which is the goal here, is now you just work with the exponents. How would you solve this? You put it equal to each other. 5x is equal to 1. How do you solve 5x equals 1? That's an algebra 1 problem. If I want to get x by itself, do I divide by 5 or do I divide by 1? Well, you divide by 5. I shouldn't have to show you that. Final answer here is 1/5. See, they're getting different now. Okay, the last two are going to be, again, just maybe a little bit different, a little bit more rigorous. So don't think they're all simple. Here goes number 5. I should get some new paper. Log 49 equals 7. Oh, no, that's not right. It's log 49, 7. I know sometimes you see a 49 and a 7 and you think the answer is 2, not here. So that's why just show the steps, show your work. Log 49, 7 equals x, right? I need these to see all these parts. I'm going to change it to exponential form. That'll be 49 to the power of x equals 7. Now we're going to get the same base. Well, 7 is a base here, and can I write 49 as a base of 7? Yes. That is 7 squared is 49, and then to the power of x. And 7, even though it doesn't show a power, we know that's 7 to the power of 1, right? Everything bases in exponents, bases in exponents. And you're left with 7 to the power of 2x equals 7 to the power of 1. That's the goal, to get these bases to be the same and match. Again, once you get them to match, it doesn't matter what they are, you just solve up here. How do you solve 2x equals 1? Well, divide by 2, divide by 2. X equals 1/2. Okay, that's number 5, last one. Number 6. Log 81 1/3. Ooh, tough one. All right, this one's different from the rest. So again, we're going to put log 81 1/3 equals x. All right, you got to add that. Now we change it to, convert it to exponential form. We go counterclockwise, starting with the base. 81 to the power of x equals what? 1/3. Always look to the lower number, and that's probably going to be the base or a number lower than it. The base is going to be 3, but remember we want no fractions, but the base is still 3. I'm going to first write that as a base of 3. 81 is 3 to the power of 4. 3 to the power of 4 is 81. So that's going to be 3 to the power of 4, and then you have your x out there. Equals 1/3, and 3 has a power, right? We want everything to have a base and a power. 3 has a power of 1, right? This one will be what? 3 to the power of 4x, right? Those multiply. A power raised to another power is the power rule, multiply. And then this one, what do we got to do to this? We have to move it up. Remember that? We don't want this fraction here, so we move this up. And if that's a positive 1, when you move it up, it'll be 3 to the power of what? -1. All right. So we got 3 to the power of 4x equals 3 to the power of -1. Well, once we got the bases to match, we can kind of drop that, and then you just solve the equation up at the exponents. How do you solve 4x equals -1? Well, divide by 4. I'm going to get the x alone. That'll be x equals -1/4. All right. Okay, good luck with this assignment. Make sure you understand the one from yesterday and this one very, very well. Good job.